Hello, everybody. Welcome back to Planet X News. It is May 24th, 2017, and we are here this morning, or actually this afternoon, with our physicist, and we're going to be discussing this incredible footage that I recorded on the NASA SETI website. And yesterday, a lot of you were able to witness this footage because I was live streaming it for like 4.5 hours on YouTube. And we're going to go ahead and jump right into this information. But Doctor, how is your afternoon so far?
Very well. I'm very well, thanks, Scott. And yours?
Not too bad. Not too bad. It's been pretty active. I've been up since 4 o'clock this morning, you know, continuing to go over a bunch of information and go over this footage. But whenever you saw this, this SETI imagery on the SREM, what did you think about this?
I thought, that's amazing. Look at that thing. It finally shows its face, or maybe they failed to hide it properly.
Yeah. I'm going to go ahead and share my screen real quick so everybody can take a good look at this. Whoever didn't get to see it yesterday. Do-do-do-do. Oh, yes. There we go. Oh, ladies and gentlemen, if you have not seen this footage, this is coming from the Stereo A. What is that? The HI-1. This is coming from the SETI website, controlled by the United States Navy, Observatory, and NASA, the boys in blue. And something just told me yesterday to go ahead and take a look at this footage because it had been about a week since I've actually looked at this particular camera. And off to the left, you'll see bursts of energy coming from the sun, and you will see the Earth. And if you follow my cursor, here is the Earth right here, right there. And they have this other small planetary object right there labeled as Saturn. We're not too sure about this, this planet being Saturn at this time, but right over here to the right of your screen, you're going to see a large object appear right before your eyes. You can see that it's rotating, and I'm going to actually slow this down just one click. And this was the imagery that we were live streaming yesterday. And this is between May 19th and the end of May 21st, I believe. And this object, it appears to be spinning. It appears to be a very, very large spherical object. Naturally, it caught my curiosity. So, Doctor, whenever you saw this imagery on the SREM, what was the first thing that came to your mind? Because I was completely floored by what I saw.
Well, you know that look watery substance it seems to have. That's what you would expect to see if there's plasma on the surface of this object, because plasma has this swirling around motion because the object, of course, has an electric field, and then it causes the plasma to swirl around and make eddies, and it almost looks chaotic and fluid-like, because that's what it is. It's a gas in the plasma state, and it's flowing around on the surface. So I think that's actually plasma on the surface of the star. I think it's a star, because it's got plasma, of course. I mean, I don't think a planet could look like this. Even if it was spinning very fast, this actually looks like a fluid substance on the surface of this object. So, and then I looked at it and I saw how large it is, and it's right behind the Earth. So if it's close to the Earth, I would say it's 5 to 10 times larger than the Earth, which would make it half the size of Jupiter to the size of Jupiter. You know, it's difficult to tell in the SREM images, but it could be slight. I mean, that's the minimum size if it was very close to Earth. If it's further from Earth, then it would be larger than that. But this is the typical size we would expect of a brown dwarf star. Remember, the first one we saw in 2007 was 1.7 times larger than Jupiter, so nearly twice as large as Jupiter. So this would be the typical size we would expect. It cannot be very far from Earth. If it's very far from Earth, then the size becomes enormous. And the kind of detail we're seeing of the surface, I don't think it's that far from being right behind the Earth.
Yeah, something that I noticed whenever I was looking at this, you can see as the object comes into view, the Birkeland current line. Ladies and gentlemen, the line that's going straight through the Earth, this is the Earth right here where you see my cursor. Yeah. And they refer to these lines as Birkeland current lines. Yeah. And this has something to do with the electrical energy. Is that correct? These Birkeland current lines?
Yeah, it does. It's got to do with what the camera sees. It's overwhelmed by usually the brightness from the planet, but in the SRAM images is the amount of particles coming from that little speck. So then it creates this sort of vertical line right through it. But you're right, the vertical line below Earth becomes very thick.
Yes.
And that almost looks like it's two lines and therefore two objects there, you know, all almost superimposed on each other.
Yeah, because I could see the reaction when this object comes into view. It does start to react, and so does the sun off to the left. When the object comes into view, you can see that the sun definitely starts to react, and we saw that that spike right here at the bottom. It comes in so fast that you can barely see it.
There are lots of jets. Look, we've just seen a jet just seeming to come off the sun, but the sun doesn't usually have jets like that. So it's probably an object close to the sun. Look, jets all over the place. These brown dwarf stars, I found out recently, are prone to having these kinds of jet ejections. So that's more evidence that these objects are everywhere in this cloud of debris and ionized gas, because what we see there is not the background stars or anything like that. This is debris and ionized cloud material inside the inner solar system, which can only have been brought in by these brown dwarf stars.
You know what I'm just noticing now that you're mentioning these jets coming from the area of the sun. Now that you're mentioning that, I am seeing them come from all different directions and angles.
Yes.
Which it would be impossible. It would be impossible for them to be coming from the sun, because some are coming downwards, some are coming upwards, some are coming directly outward. And then there is the one up here in the upper right that well, you have to watch very carefully because it's only there for a split second.
We just saw a type of ejection coming from off there. So there's obviously an object there. And
now
these
that I see this,
stars,
there's definitely, okay, I could see this now. There are definitely multiple objects. They're out of the screen, ladies and gentlemen. You can't see them. But if you just pay very close attention, you'll see these black, they look like spikes. Just a dark black spike. They're coming from every direction. And you're referring to those as jets.
Yeah.
Pretty amazing.
Jet ejections, everywhere you can see. And there's a large one coming. We sometimes see it right at the top. It goes right across the image. It's so huge.
Yeah, I did see that. That's the one that caught my eye. Yeah, it goes right across the top up there.
Yes, that's right. So these images are actually very, very busy. There's lots going on.
I wish there was a way to clear this, you know, the SRAM imaging. Oh my God, it is. It's so busy. There's, you know, it's so distorted, but you know, I mean, for what it is, you can pick out things that, you know, you're supposed to be seeing, is what I'm saying.
Yeah.
You know, so it does do its job, but then things that you want to see, sometimes it's very, very hard because it seems so pixelated, but really these aren't really pixels. They're actually like little rounded pixels. I don't even know what to call them.
They're actually particles hitting the detector. That's why the detector says, oh, that particle comes from that region. And that's why it results in this image. Notice there's actually an object moving across almost right in the middle of the image. And yeah, that one.
Yeah, I did notice that also.
Yeah, and then Saturn is not Saturn because it's moving to the right, and Saturn has to be behind the sun. And if Saturn's behind the sun and it moves very slowly, the camera would have to be moving to the left. But the camera is on a satellite that has to be moving with the rest of the planets in the solar system. So Saturn would have to move in the opposite direction, which is to the left, so that the satellite moves to the right. So that's not Saturn. Plus, it's difficult to see Saturn way out in the distance at the outer edge of the solar system behind the sun when we have so many clouds of ionized gas in the way. So I think that object is actually quite a bit closer to the camera than it appears.
Yeah, because I'm going to flip over real quick.
Yeah.
I'm going to flip over real quick to the other screen. And when we're talking about these ionized clouds and these big gas clouds, this is what I was showing everyone yesterday, is this image right here. And ladies and gentlemen, you can see all of this.
Yeah.
I mean, it is a huge dust cloud, a huge gas cloud. I've only seen this, I mean, on rare occasions, I see all of this mess, you know, flowing across the H1A camera, the red imagery. But yeah, they're showing that, and they have that object labeled as Saturn, as you can see right here where my cursor is, and you see the Earth right here. But then all of these, you know, Doctor, this huge illuminated cloud, I mean, would this be one of those gas clouds where my cursor is?
Yeah, definitely. Those are always associated with a brown dwarf star. In other words, it's so illuminated that there's probably a brown dwarf star inside it or very close to it somewhere. And one of those that probably still has a dark core. The rest of the clouds we see in the background may be clouds from brown dwarf stars that have been able to restart fusion reactions on their surfaces, and they've just blown their clouds away. So they're just filling the solar system. And I see this a circular object there that appears in that dark region. Yeah, did you see that? That looks very strange. Yeah,
you're talking about this one,
like
right?
Like a ring. Now, just above your cursor in that black black region, yeah. You can see it. Yeah, it's a ring-like structure there.
Oh, I do see that.
Yeah.
Oh, I do see that.
Yeah. That can also be associated to brown dwarf stars because they have this gaseous envelope that forms a ring structure around them. So yeah, that's why I look for these ring structures. And there we are. There's one there. Yeah. There's lots going on in these.
Yeah, there's a lot going on in these images. And you know, yesterday I did a report on this solar tsunami.
Yes, and I just said that doesn't look normal. Hey.
Yes, we have the SDO footage up. This is the current 48-hour loop, And this solar tsunami or this solar shock wave, this region is what we're talking about. You'll see it right here. It's kind of egg-shaped. You'll see it start to kind of collapse on itself. And this is what is sending the coronal mass ejection, or the CME, towards Earth. I did a short video on it this morning, letting everyone know that it's going to be a direct hit. It's going to be a direct hit on the Earth, pretty close to the end of the 26th, going into the 27th. Yeah. That's the spikes that I showed on the CME tracker, and also the solar wind predictor model. Both had it on or about the end of the 26th, going into the 27th. Yeah, it just looks like it collapses on itself right there.
Yeah, it looks like. Yeah, it looks like a coronal hole opens up really, really fast, and then it's almost like the plasma is pushed away from it so fast, and then almost pulled up from the surface of the sun, and then it collapses back.
Mm-hmm.
And that I would attribute to an object close to the sun pulling on the plasma and shifting it, and then it lets go and it collapses back. This is exactly what you expect when these brown dwarf stars, their magnetic fields, which are very high, connects with the sun's magnetic field and pulls out the sun's magnetic field lines. And then this is what happens when coronal holes open up. But here it's even more than that. It's like it just pulls the plasma right off the surface, and then it collapses back.
Now, this did show on the SOHO imagery, it did show the coronal mass ejection. Normally, you know, we see them come from the right or the left side of the image because they're never, you know, they're usually not Earth facing. But this one, this came directly towards the occulter, you know, the big black object on the SOHO imagery that blocks out the sun's corona. And you can see that it most definitely, that coronal mass ejection is coming directly towards the Earth. And whenever I did look at the CME tracker, it's dead on. I mean, we are going to get hit dead on with that on the late on the 26th, going into the 27th. Now, what do you think is going to happen with a coronal mass ejection like that impacting the Earth dead on?
It's going to hit everything that we've talked about before. It's going to cause earthquakes, volcanoes, weather to go crazier than it already is. The planet wobbles more. We may have grid problems, electric grid problems. All that will probably happen in different parts of the world. Depends. We will probably get auroras. Yeah, that's it. It's going to be.
I could imagine the auroras. Yeah. Wow, they should be really intense. At the end. So. Now, remember, folks, this is going to be pretty much towards the end of the day on the 26th. You know, depending on where the Earth is in its rotation, they're using UTC time. I absolutely hate that universal time. What is that universal time? What is it? A difference of like 4 hours between
for
regular
you,
time?
On the East Coast of the United States, yes, I think it is 4 hours. Yeah. So for you, it will happen at the beginning of the 27th.
Yeah.
Yeah.
Yeah, right at the beginning. Actually, what I was looking at would be, it looked maybe between 11 p.m. and midnight on the 26th.
Yeah.
Going into the 27th.
Yeah.
And something that I also am noticing, remember in you know, all of these past weeks and these past few months, Remember how every time the sun was turning from the left to the right, we were always seeing these big coronal holes developing on the left side.
Yeah.
Look at the left side of the sun now.
Yeah.
It's looking pretty good, but
Yes.
we have this coronal hole from the top,
Yeah.
and it's basically scarring its way down pretty close, I would say 2/3 of the way down towards the sun's equator. And then we have this one that's just turning
and they
away.
are coronal hole.
Yeah.
Yeah, on the right. I think it's got to do with the position of these brown dwarf stars that are orbiting the sun. They're obviously more towards the right, according to our view of the sun now. And before they were right in line with the Earth and the sun. And they probably some, you know, further up on the northern hemisphere. And that's why we have coronal holes there.
Yeah, the sun definitely looks weird.
Yeah, you know, although it looks normal on the left, almost normal, don't forget it's a lot less bright than it used to be a few years ago.
Yeah, because there's no corona on the bottom. There is very little corona to almost nothing on the top.
That's right. So, yeah, the sun is definitely being affected by what's happening to it. And these objects are obviously draining its electric potential energy as well as drawing plasma from it, because we've seen the objects from 2012 do that. So and whenever they're using cutoff lines, it's because these objects are going right into the sun's corona and probably connecting with it and pulling plasma out. And of course, they don't want us to see those objects in the corona. That's why they put the cutoff lines there.
So we're definitely going to have a few interesting days. Let's see what today is. Today is the 24th. So in 2 full days, we may see an all hell breaking loose situation.
That's right.
Depending on how strong this CME is.
That's right. I mean, because it's directly directed towards Earth, it will, I think, cause quite a lot to happen on the Earth. And don't forget, if we start seeing a lot of volcanoes, that's probably not too bad, especially in the areas where there aren't too many people, because the volcanoes actually release pressure, so we don't get such large earthquakes. If we don't get a lot of volcanoes going off, then we probably get larger earthquakes at the fault zones.
Yeah, I've been watching some volcanoes lately, and the volcanic activity is picking up. We had over 30, I think it was either 37 or 38 volcanoes that were in full eruption the other day. And ladies and gentlemen, what you're looking at here, this is the coronal mass ejection tracker. Once again, this is something put out by, you know, another NASA tool. And the little yellow circle right here, this is Earth. The middle white circle is the sun. And you can see the CME being ejected from the sun. If you look over here, you can see that is a dead-on impact. Right where my cursor is, that is a dead-on impact, and there's no doubt about it. We're going to get hit with that. We're going to get hit with that.
Yeah,
at the end of the 26th.
We definitely are. Wow.
See how it spreads out after it passes the Earth? It actually gets bigger. Its energy.
Yeah. Well, it's likely to do that. Don't forget, when you blow smoke rings, they get larger as they move away from the source. So you would expect it to get larger as it moves away from the sun as well, like smoke rings.
Yeah, this is going to be an interesting.
Definitely.
This is going to be a very interesting period.
Yes.
These next couple of days are going to be.
Yeah.
They're going to be very interesting. I'm going to pull up the actual solar wind prediction model real quick, because this gives an intensity of the of this ejection, the CME coming our way.
And then we see the spike in the density. The radial velocity is not going to go up very much, but this is not about fast solar wind because it doesn't come from a coronal hole as such.
Yeah, the velocity.
It's actually
the velocity actually drops a little. Well, not really. It goes up a little. It drops and then it goes up a little bit. But we're looking right here, ladies and gentlemen, where you see this heavy spike, this very large, prominent spike on the plasma density right here, and it is on the timing. If you peak, this is probably going to be, like I said, pretty close to. This is UTC time, so you know, maybe between 10 and 11
p.m. on the 26th.
Yeah. Now, if you look over here, when you see this CME coming towards the Earth, watch very closely as it gets close to my cursor how it turns red. It literally turns red right as it's passing through the Earth.
Yes, yeah, it does. That is interesting indeed. Yeah, what that is why it turns red is because fast solar wind is overtaking slow solar wind. That's why the density will increase at certain points. Happens there. The fast solar wind overtakes the slow solar wind right at that point. So we get the density spike.
Yeah, if you pay close attention to this, it looks like the more energy coming from the sun right where you see my cursor. It's a good thing that we were actually past that, but the predictor model doesn't go out that far, but I'm sure we're going to get a little bit of an effect from the aftermath of that CME that's trailing behind it, because the predictor model runs out before the sun will turn, and the sun will turn, and I believe, we're right on the fringe of the last part of that. So I would probably say from the 26th, 27th, possibly even the 28th. These may be 3 very busy days.
Yeah, and the effects stay on for a while. It doesn't. We don't just get hit and then it goes away, because the current it produces in the ionosphere, the effects of it stays around for quite a few hours. So, you know, or to a few days, depending on the speed of the wind as well.
Boy, that is a direct hit. That is a direct hit.
Yeah, it is. And it's not going to be nice for our little planet.
Yeah, it definitely is not. Now, I'm going to go ahead and resort over to the article that you wrote on this, and let you take over from there.
Okay, thanks, Scott. Okay, so I just put this together quickly because I wanted to analyze what was going on in these images. And for me, the best way to think about it is to look at the images carefully and then, you know, start to indicate what I see there. And I see I didn't even indicate that that ring that I saw when you was showing that footage. I hadn't even noticed it before, so I didn't put an arrow with it. But what I did indicate here was that little object moving there, which I spoke about when you were looking at the footage above the, that one indicated by the blue arrow. And then below that, it's obvious you see the illuminated cloud of gas that's associated with a brown dwarf star. And it's illuminated, obviously, because there must be plasma ejections going on inside it. So, and then I mentioned that Saturn is moving in the wrong direction, so it cannot be Saturn. And then Earth is important because the object that appears behind Earth. Also, it's obvious that the solar system is full of clouds of gas. That's what it is. It's clouds of gas. It's so dense now that it's obvious that it's clouds. It's not. And all these specks, like I said in a previous article, are part of the debris inside the inner solar system. They're not background stars, because we see them in front of solid objects, large solid objects, like that circle, that large circular object that sometimes appears. So I guess that's what I had to say there. We can scroll down a little bit more. Then I indicate that object that appears in the HI SRAM images. This is from May 20th. And I think it's quite close to the Earth, because if it's not quite close to the Earth, it would have to be huge. That's right. It would have to be a main sequence star. The size of the sun or larger. But if it is quite close to the Earth, then I would say it's between half the mass of Jupiter, half the size of Jupiter in radius, to the same size as Jupiter. Or it could be a little larger, but these objects are usually not much larger than the brown dwarf, the blue brown dwarf that you took a picture of. And that was 3.3 times the size of Jupiter. I don't think they should be much larger than that, although anything is possible. So I would say it's quite close to the Earth. And I would say again that I think it's a brown dwarf star, that the surface of the object looks like I would expect plasma to look like on the surface of these objects. Of course, it's not as hot as the sun, so we don't have the same kind of light emission that we get from the sun. So it's actually easier to see the motion of the plasma on the surface of the object. And it looks fluid-like. It looks like it's almost like water. And that's what I'd expect plasma to look like on the surface of these objects. So that's why I think it's a brown dwarf star.
There's definitely a lot going on that object. You know, when I saw it yesterday, I was absolutely amazed. I sat here at my computer and I just stared at it and stared at it, and I couldn't believe my eyes. You know, once again,
isn't it amazing?
Yeah, it is amazing. What do you think that this object would look like if we were actually able to see it in the sky? You know, if they would stop all of this chemtrailing, and obviously they have the ability to hide these objects or cloak them or whatever they're doing, because if we can see, well, we can see Jupiter with the naked eye now during this period, but it just looks like a tiny little, tiny little light in the sky.
Yes.
Do you think that we would see this object in the same way, just a tiny little light in the sky, or we wouldn't be able to see it at all?
I think it's quite close to the Earth, so we would see an enormous object in the sky. And if it's at night and it's on the opposite side to the sun, okay, so there's sunlight reflecting off it, just like we see the moon with sunlight reflecting off it. And that is if it's not, it doesn't emit light. Now visible light, because some of these brown dwarf stars do not emit visible light. They emit little bits of visible light and mainly infrared light. Now this object, because it's got plasma on it, may be emitting its own light already. If it doesn't, then we would only be able to see it reflecting light from the sun. But I think it would look quite huge in the sky, actually. Because if we had Jupiter close to the Earth in the sky, it would just about fill the whole sky.
Oh, God. Yeah, people would have heart attacks all over the world.
Yes. It doesn't mean it's going to harm the Earth, because we could be on one of Jupiter's moons that are close to Jupiter, and we would be fine. And I don't think this object is as hot as the sun, so heat would be a problem, but I don't think it's as hot because these objects, when they come into the solar system, are quite cool. And then slowly they heat up and they start emitting some visible light. If it does emit visible light, it probably will not be white light that the sun emits. So it might be dark yellow. It might be some other colors. You know, it could be orange color, something like that. It could be emitting those colors, but and not bright, not nearly as intense as the sun. So there would be some heat and radiation coming off it, of course, but not nearly as much as the sun, which is why it's probably not as dangerous for us to be as close to the sun. Because if we were very close to the sun, like Venus or Mercury are, our planet would heat up to the point that life would just about be impossible. But these objects are not as hot as the sun. So we're probably getting quite a bit of radiation coming off it as well, because it must emit radiation. And of course, it's got a strong magnetic field. And the magnetic field will affect the Earth's magnetic field. It would cause the Earth to wobble. Maybe that's why it's wobbling so much, because this object is so close to us. And it would have caused the poles to shift like they are doing right now, which, of course, that's what's causing the Earth to wobble. So, I mean, we are seeing effects on the Earth that are very likely to be caused by an object like this. And if it's this close to Earth, then there we are. We have our answer why it's occurring.
You know, I had a good question.
Yeah.
I was actually thinking about this the day before yesterday, and once again, you know, ladies and gentlemen, I go through all of the worldly events around the globe. I try to keep my eye on everything that's going on around the world right now, dealing with weather and climate chaos and all of that nasty stuff. Would an object like this be a huge, or have a huge, strong electrical force of some kind? Because the reason why I'm asking is, all of a sudden, over the course of the last week or so, we have seen around the world all of these crazy lightning storms, some of them illuminating the sky, and the lightning literally going horizontally instead of vertically, and just staying in the sky, to the point where people can take pictures of it. But in the same instance, a lot of people are getting killed by these lightning strikes over in India, over in the Middle East. I think in one day, 9 people were killed at once. And then I think the running total is well over 40 people. Last week or the week before, 40 people struck and killed by lightning instantaneously. So that's why I was kind of thinking, you know, if these objects have a strong electrical force, you know, is it possible that they would start to provoke more lightning, more electricity in our atmosphere to produce these lightning storms?
Yeah, definitely, Scott. What happens is these objects will emit particles. Remember, they're always plasma particle flux transfer between these objects. When the Earth gets hit by a whole lot of these particles, they enter the magnetosphere, they go into the ionosphere, and they electrify basically the ionosphere. So if there's a lot of electricity in the ionosphere, then it will cause electrical current to actually flow into the atmosphere. And then it tries to equalize the potential difference, because there's a large potential difference then between the ionosphere and the clouds below that get ionized as well. And then there's a potential difference between those clouds and the surface. And so if there's a lot of current going on, a lot of charge in these clouds, then there's a lot of lightning, which is basically the potential difference equalizing. This is what actually causes lightning. And there will be lightning across the sky as well, as different portions of the sky or have a larger charge or more charge than other parts. So they equalize across the sky, and they equalize between the sky and the surface of the earth, which is ground. So basically the charge tries to flow to ground, and that's what causes these lightning strikes. And they are expected to increase, of course, because we are getting hit by more and more of these ionized particles. We're not just getting them from the sun, we're getting them from these objects that are, of course, as you say, if they are close to the earth, that's exactly what we would get. We would get more charge coming into our atmosphere.
Well, somebody just listed in the live chat, a 5.7 magnitude earthquake just went off in Alaska.
Wow, that's a strong one. Yeah.
Yeah, these lightning strikes, the information that I was reading, I think I read 6 or 7 articles, all bunched together, and they were all around this time, the 17th, the 18th, the 19th, the 20th. So that's why I was asking that question, because I found it kind of odd. You know, I mean, I lived in South Florida. I've seen plenty of lightning. I used to like watching it during the storms, and, you know, down in South Florida, yeah, you get big lightning storms. But these lightning storms that I saw in some of the short video and the photographs was just absolutely amazing. And, you know, it's hard to catch lightning on camera because it's light. It comes so fast, you have to actually try to predict when the lightning strike is going to occur so you can click your camera. And these lightning strikes, they just stayed in the sky horizontally from one end all the way to the other. Just multiple lightning strikes all the way across this horizon. It looked like something out of a sci-fi movie. You know, and that would be
that's definitely
scary.
Not normal.
Yeah, that would be very, very crazy.
You're right, Scott, because if they just stay there almost continuously, like a continuous discharge, that is not normal. That means that's charge in the clouds beyond anything we've ever experienced. And it keeps feeding it. So it's coming from outer space, you see.
Yeah, that was, you know, we may have to maybe check into that a little bit and you know, pull up the information on these lightning strikes and do a little live stream on that, because to tell you the truth, I think we're going to see a lot more of that with all of the crazy weather that we're having. You know, last week I mentioned that the temperatures where I live, they were like close to 90 degrees the entire week. Very, very humid, very, very hot. And then this week, we are just hovering near 70 degrees. So again, you know, this constant severe wobble of the earth, you know, and then they were having snow in areas of the United States where normally it would be springtime. It's towards the end of May. You know, the flowers are blooming, the bees, and they're out, and it's, you know, it's supposed to be a beautiful time. And the next thing you know, people are getting hit with 40 inches of snow. You know, just absolutely reckless weather. And I mean, I'm not buying the climate. I'm not buying the climate changing. Yeah, it's changing, but it's changing on a radical basis. And then when I looked at the jet stream, which we're going to do before we end this live stream, you know, the last time we looked at it, how erratic it was. Well, listen, this time it looks like a big hot mess.
Oh my.
Yeah. But what do you have here for us on this this imagery here?
I just tried to show all the jets. You see all those jet ejections? I don't think they're coming from the sun. They're coming from an object close to the sun. There it is. There it is. There's another one above that. Yeah.
Yeah, they're faint in the images. When you watch
some of them are faint. Yeah.
You can see
like
it.
that. Yeah. And so I tried to point out all these different jets, and some of them, I think they actually tried to hide them. That one in the third image is very faint, but it goes almost right across. Yeah.
Here, we have a better look at one here. Now, this is the one I was referring to that was just
There
coming up out of nowhere. See, now that
Yeah,
could not
exactly.
even that could not even possibly come from the sun. This one here and this one here, they could not possibly come from the sun.
Yeah, that's right.
Yeah, pretty incredible.
And there's one across the object, which I think is a brown dwarf star there as well.
Oh, yeah, I see that.
Yeah, that one. Yeah, so there are lots of them around.
Yeah, you definitely have a good eye for detail there in capturing that. I didn't see that either, but now, yes, I do see that right across, almost a little above the halfway point, right across the top there.
Yeah. There's a nice,
jets.
more of those. And there's another one across the object there now on the bottom part. Yeah, that's another jet, a small jet I thought there was there. In the image, that image on the left, there's a jet coming across the object as well. You see the yellow arrows pointing to it. Now below that, that
right here.
one, yeah. Yeah, you see it's quite faint, but there's definitely a jet going across there again. So
then there's a nice one right here.
And there's a thick one there. You see? There we are. And these are not normal. The sun doesn't do this kind of thing, all these thin jets. So I don't think it's from the sun. I think it's these brown dwarf stars. They emit these jets. And
well,
there are so many. Yeah.
There's a lot going on in these images.
There's a lot going on. Yeah. And there's one going right across there.
Yeah, if you're not used to looking at these images like we are, you would just say, what in the hell is this jumbled bunch of static mess?
Yeah, it is. I think they meant for it to confuse us. You see that last one, it looks like there's a little black object above the Earth, and it looks like that jet is coming right from it.
Yeah, right where my cursor is here.
Yeah, that one there. You see? And so there's lots going on, lots and lots of jets. And when I first started looking at these images, I used to look at these jets and I'll think, what is this? What is going on? I have no idea. But now I realize these brown dwarf stars, they emit these kinds of jet ejections. And that's why they are all over the place.
Now those jets, is that would that be an electrical type of ejection or a plasma ejection of some kind?
It's a type of plasma ejection, and there's a discharge going right across it. So it's actually particles emitted from the star, and then it's discharging. So it's ionized and therefore it emits particles and radiation. So excites the particles are excited. When they come back down to the ground state, they emit photons. So, but the SRAM images, we are basically looking at the particles emitted from the area. Right, I think that's my last image. You can actually see that large circle we usually see in the HI images.
Yeah. Mm-hmm.
And so I point to it at the top and at the bottom. And this object looks like at least twice the size as the brown dwarf star that we first talked about. So this probably would be another brown dwarf star, probably even larger. I've said before it could either be a brown dwarf star, a main sequence star, because it's really quite huge. But still, don't forget, if this object is the same size as Jupiter, where we can see the watery kind of plasma effect on it, then it would still be within the size that we'd expect a brown dwarf star to be, twice the size of Jupiter. So it could still, but then we have two of them there, one behind the other.
They just said in the live chat, another 5.8 just went off in Alaska.
Oh my.
We may be.
Oh my.
We may be getting some of this this energy heading our way already.
Yeah, that may have been from something that happened before. Maybe we had a coronal hole facing the Earth a couple of days before. I don't know.
Yeah, well, we did. We had a rather large coronal hole across the entire equator of the sun, and it was Earth facing.
So that's probably where this is coming from the fast solar wind coming off that coronal hole. Wow, look at that. That's a big two big earthquakes there.
Yeah, that was a magnitude 5.7. Depth 2 kilometers. Ooh.
Wow.
Man, that's shallow.
It is shallow.
What is this? What the? A 3.4 in Ohio 28 minutes ago. Ooh.
Oh my goodness. Whoa. That's close to you, isn't it?
Yeah, depth is 6.76 kilometers. That is very shallow. Magnitude 3.4. That was reported by the USGS. So you know that they downplayed that. So that's probably near a magnitude 4. I know they felt that. I know they felt that because this area of Ohio is flat.
Wow.
Turn on the satellite imagery on this baby. Or wait a minute, this might be the region that is in the Appalachians. There's Jackson, Ohio. Get in there a little bit closer and let's see exactly where this baby went off. Oh, in a wooded area, the epicenter.
Wow.
But there's houses there. There's neighborhoods. There's neighborhoods all there along Route 93.
Wow. Yeah.
So there you see, 28 minutes ago, magnitude 3.4. 2 kilometers south of MacArthur, Ohio. So, folks, if any of you live in that area, you just had a pretty nice sized earthquake there for Ohio. You can see things are really kicking off. There's the 5.7 right behind it, magnitude 5. Let me just roll in here because sometimes these are stacked on top of each other. Yep, they are. Magnitude 5.1, magnitude 5. There's a 5.7. Yep, they're stacked on top. There's a 5.3. Well, things are kicking off. Matter of fact, I think Dutch did say something about the area of the Caribbean being kind of quiet. He thought that was kind of suspicious. And bingo, here you go. Magnitude 4.6 and a 3.91. Oh, we have an update. Here we go. Yeah, it just updated itself here. Multiple earthquakes here in the South Pacific. 5.8, 5.5, Indonesia. These are multiple earthquakes. I could see it. 5.8, 5.6.
Yeah.
Well, it looks like things are definitely kicking off. Small quake on the New Madrid fault, magnitude 1.83 9 hours ago in Missouri. What do we got going on over here?
Lots in California. Little ones.
Yeah, what's this little tiny little thing here in Wyoming? Tiny, tiny. Can't even get on it. It's so tiny. You see a little orange dot?
Yeah.
Yeah, there's a lot going on. I don't like the idea they don't report any of this going on in the Cascadia area. You notice that? They're having a bunch of earthquakes and tremors all in the Seattle area, right here along Vancouver, all of this area, but they're not appearing.
Yeah, they don't want to warn people.
Oh, they had an earthquake in Arizona. That's rare, 2.6. Couple of small quakes in Nevada. Let's see what we got going on over here in Ohio since we're here, or California.
2.46.
San Francisco, 2.3.
2.3,
Yeah, they're about their average quake information. Just as long as we don't see, magnitude 6s and 7s along this San Andreas fault. But you can definitely see there is some activity. This is a very, very strange earthquake here. This MacArthur, Ohio, magnitude 3.4. You could probably think that's definitely probably a 4. They downgrade these earthquakes very, very quickly.
Yeah, and Scott, I was going to ask, is that
Albania?
Greece? Yeah. No, Albania. Strange.
Yeah. I just had a friend of mine leave the other day, and she is going on a 30-day vacation to Greece. She has never been out of the country, and I told her on Friday she was leaving. She was leaving over the weekend. And I told her, I said, listen, you better be very, very careful going over to Greece. I mean, you're going to be feeling earthquakes on a daily basis. And she kind of shrugged it off, and she was like, oh, no big deal. But I didn't have an earthquake map to show her exactly what's been going on there. So she's already there. She's going to be there for a month. And boy, oh boy, is she going to get a taste of earthquakes. Here's this earthquake here. I'm kind of curious what they're saying about this earthquake here in Ohio. So I just want to pull up the information. I want to see what they're saying on this. I just want to see if there's any other stations. 6.8 kilometers. Boy, that is.
It's close to the surface. It is. Very strange.
Yeah, that's very strange. I don't know if there's any fracking wells. I'm sure there are, but I didn't see any on that imagery there that we looked at.
Yeah.
And we're going to see. Oh, here we go. See, magnitude 3.6. Oh, just like I thought. Magnitude 4.20, 4.28.
Wow.
Okay, this is what I mean. This is total crap from the USGS. Okay, this was reported right here. I mean, you're looking at it with your own eyes. This was reported.
Yeah. At 4.2.
4.28. 4.20.
Sure.
I knew it.
Yeah. They downgraded it.
And this is their preferred reading. Magnitude 3.4. Well, to me, there's a big difference. A magnitude 4.28, magnitude 3.6.
Yeah.
So what are they telling me? That this device here, you know, yeah. This is why I hate looking at the USGS, because I know what they do. You know what I mean? And that's just not right. Oh,
No.
what's this that just occurred here in Canada?
Oh, Canada, yes.
Magnitude 3.3, Elkford, Canada. I think that I think we're gonna get lit up here. I think the Earth is going to get lit up with these earthquakes over the course of the next several days.
I think so. Yeah.
Yeah, that was a 4.2. We got down here in Argentina a 4.7, a 4.0 in Chile. Poor Chile, they get hit so many times.
Yeah, they do.
Oh, what do we got going on over here? Yeah, some of these earthquakes on the other map, they don't show up on that other map, so you're kind of forced to look at the USGS. There's a 5.5 there, 5.6. Oh, this 5.6, that was a shaker. They felt that, and they issued a tsunami warning, or at least they were looking for one. 4.5 right outside of the coast of Saudi Arabia, whatever that is, Yemen. Yeah, 4.6. Well, it looks like the Earth is going to be rocking and rolling and shaking and shimmying for the next several days. I think it's going to get a lot worse.
Probably is.
Just my opinion. I think we're going to see some stuff. You know what? While we're here, before we end our stream, let's take a look at the magnetosphere, magnetoplaza, and let's see what's going on there. Yesterday, I was looking at the magnetosphere, and the one side of it was bent completely in.
Wow.
Yeah, it was. I've never seen it like that before.
My
kind of strange, but let's see if it.
Yeah, well, the Earth is getting hit by solar winds from different directions because there are so many stars in the solar system.
Yeah, that looks relatively.
Yeah,
normal.
It doesn't look too bad at the moment. Yeah. It's the quiet before the storm.
You know, you took the words right out of my mouth. That's what I was going to say, because I was looking at all of these models earlier this morning, and then about a half an hour before we went online, and I didn't really see anything that was abnormal. Everything looked relatively normal. Even the solar winds. The solar winds were down a little bit. I mean, they were nothing to write home about. Yeah, they're about 525 miles or kilometers per second.
Yeah.
And we're relatively in the normal range here.
Well, it is a little fast for slow.
Yeah, a little,
but it's fine.
Not too bad. You know, at least we're not up in there into the high 600, 700, 800 kilometers per second range.
That's right. Yeah. Yeah, it doesn't look too bad.
I even looked at the radiation levels. I mean, they were elevated, but they weren't as bad as what we're normally seeing as of lately.
Yeah. Oh, there we go.
Yep, there it comes.
The particles coming in from behind the Earth.
Oh, yeah, I guess I spoke too soon, because about, maybe a little over an hour ago, I looked at this, and it was, it was kind of greenish yellow. And, well, obviously that changed.
Yeah, there we are. Particles coming in.
Yeah, well, probably within the next several hours, things will probably change, most definitely. Yeah, and I would say, hey, listen, anybody who Anybody who lives in any of these active areas, earthquake, volcanic regions, just make sure you keep on top of the information. But, like I said yesterday, when it comes to these earthquakes, they come within a split second. There is no planning. There is no predictive planning like there is with, hurricanes and things of that nature, where you have models that will tell you timing and positioning. So please make sure that you have some type of plan. Don't be scared, be prepared. Those are my words. I see those words are being rattled around YouTube now. They're taking my saying, don't be scared, be prepared. I'm going to have to trademark that or something. Maybe I could get some, maybe I could get some royalties from it, But anyways, listen, Doctor, that was a fantastic live stream. Once again, thank you very much for shedding some light on newly developing issues that we're seeing around the world and in our solar system. And once again, I'm still overwhelmed at what I saw on the Secchi footage yesterday.
Oh, yes. Amazing.
You know what I'm afraid of? I'm afraid we're never going to see it again.
Yeah, but at least we saw it once, Scott.
Oh, and I recorded it too.
Yes. I mean, if we see it once, like the blue brown dwarf, that was amazing. And now we see this on the Secchi images. It's amazing. We're getting more and more evidence every day. And you are catching it.
Yeah, that's kind of making me wonder. I mean, the God's made me like, okay, look, Scott, I'm gonna have you. You're gonna see it all.
Yes, I think so.
I mean, but then again, I mean, I do my research. You know what I mean? I don't just sit around, on my rear end all day doing nothing. I mean, I am literally the majority of the time at my computer, 10, 12, 14 hours a day. I'm up in the middle of the night. I have crazy hours. I sleep 4 hours a day if I'm lucky, and the time difference between, me and you, I mean, it kind of works out pretty well. But I mean, I am literally out there doing my research. I'm trying to find answers. And sometimes when I'm out there trying to find those answers, I stumble onto a little pot of gold like yesterday. And that was an amazing find once again. And I told everybody months ago that the month of May 2017, man, it was going to be an active month. We were going to start seeing all kinds of crazy things around the world. Climate chaos, the wicked weather, the earthquake situation, the volcanic situation. And I mean, this thing with the weather, man, it's getting very, very intensely crazy. Matter of fact, I did mention that we were going to take a look at that jet stream. Let me just go ahead and pull that up real quick, and I'll let you go because I wanted everybody to see this.
Mm-hmm.
I'm going to go ahead and get this up on my screen. And there we go.
Mm-hmm. Very wobbly, isn't it?
So look, here's the big dip in the United States.
It's a big dip. It's huge.
Now that's why the weather changed over here on the East Coast so suddenly. It went from being, in the high 90s.
Yeah.
And then, down into the 70s, because you could see where the air is coming from. It's coming from the Arctic straight down. And when this hot air hits this cold air, look out, central part of the United States, Tornado Alley again. So I could only imagine, these people are finally starting to dry out a little bit here in the central part of the United States. No, they're going to get battered once again from the Gulf of Mexico all the way to the Canadian border. And that's just this country. But you can see how erratic the northern jet stream is.
It is. It's broken up.
It's a mess.
Pieces.
Southern hemisphere, look at this.
It looks even worse.
Yeah.
It looks worse. It looks terrible.
There's like 3 or 4 jet streams right there.
Yeah. Sure. Oh my.
Yeah.
Yeah.
Climate change.
Wow.
Climate change. I'm not. Look at this. Look at this going up into the central part or the southern part of South America.
Yeah. My, oh my. And it's crossing over right into the northern hemisphere.
Yeah.
That airflow.
Yeah.
From the south to the north. It's not supposed to do that.
Right there. Watch it.
Yeah, look at that. Yes.
That's amazing.
Sure.
What are they? Let's see what's happening over here in Europe.
Yeah, it's broken up.
Look at that. It's going right over the UK, just like a complete arch.
It is. Amazing.
Wicked weather. And Australia, they're getting hammered. They got to be getting hammered by something.
Yeah.
That's going directly straight across their country. And then they have another jet stream right below.
And I keep seeing air currents connecting.
Yeah.
From the north to the south, and that's not supposed to happen. They're supposed to stay separate. But that just is more evidence to the fact that the Earth is wobbling and the poles are not where they used to be anymore. So the equator is not where it's supposed to be anymore. Our equator line is not our equator line anymore. That's why the air currents are doing this. It's probably moving around and changing daily. So.
Well, yeah, because I looked at this. I looked at this yesterday, and it looked nothing like this. I mean, it was very, very erratic, but it looked nothing like this. It's completely changed.
Wow.
I would not want to be in the southern hemisphere. I would not want to be like, if you were in a ship, like a cargo ship or something. I would not want to be anywhere around this area. I wouldn't want to be anywhere around this area. Nowhere. God only knows what type of weather you're going to run into instantaneously.
Yeah.
And it can change in hours or minutes.
That's right.
But yeah, I think the United States, I think the folks in the central part of the United States, I think they're in for some severe weather coming up. If they're not already having it, I haven't checked the weather. And look what we got coming directly into Southern California.
Yeah. Wow.
Its own current just blasting right into the shore.
Yeah.
And I think this was probably warm air. And it's heading directly into the Sierra Nevada mountains. This may be the warming current.
Yeah.
Well, you know what? Yeah, this may be the warming current that they're not wanting to see. Well, well, well. Well, I guess the best that we could do is keep our eyes out and keep reporting on, what we're seeing and what we're experiencing around the world. There's no doubt about that. And I'm sure by tomorrow morning, we will have other things to talk about once again. I know you have another report that you put together. And this one is, you said, your most scientific report?
Yes, that's what I said.
Is there a bunch of math
I
in
had to do a lot of thinking. it does have a little bit of math in it, but it's actually the thinking behind it that I was, thinking about when I said it's more, it's got more physics, more
That's
of the
the word
workings
you
of,
used.
yeah, more of the workings of physics than most of the papers I've written so far.
Well, that sounds good. I will definitely schedule something with you and talk with you, and we'll get something together tomorrow and go over that information. And I am going to work on taking some of the still photographs from that Secchi imagery, and I'm going to try to clear them up a little bit. I'm going to try to work with the photographs a little bit and see what I can come up with, and maybe I might be able to come up with something a little more clearer photographs, and maybe we can take a look and see how much detail we can see on that big behemoth object out there in the distance away from Earth. But did you have any last words for everyone?
No, just thank you, Scott. This has been fun discussing this object and your discoveries. So thank you for having me.
Yes, absolutely. And listen, ladies and gentlemen, make sure that you stay tuned. Make sure that you stay tuned. Once again, I want you to share the videos that we're putting out. Make sure you share those on Facebook and share them on Twitter. Spark up the conversation. We are producing more than enough evidence to make people believe. Tell your friends and tell your family members of the situation. And listen, most of all, do not forget that we have this coronal mass ejection. We have this CME coming our way. How powerful it's going to be and the effects upon our planet, I don't know. I don't have a crystal ball, but what we've shown you is definitely the case that we are going to have a direct impact on or about the 26th through the 27th, and that energy will stay with us probably for at least another day or so. So be on the lookout. Make sure you have a preparedness plan, and make sure you stay tuned. This is Scott from Planet X News. Thank you for watching.